Hello everyone. So welcome to Undoubt Me. We are back with one more question. As you can see on the screen, this is a very tricky and quite interesting geometry problem where we need to find area of that yellow region. So this is a square and the internal areas are given, but we don't know the side of a square. Okay, so first we will try to get side of a square, and then our ultimate aim is that we will get area of square, and from area of square we will try to reduce these three areas to get the yellow region. Okay, so I hope you are clear with the plan. That's the overall plan. Let us begin. So to begin with, we will assume sides to be x. So the two straight sides where there is no bifurcation, I'm assuming those as x. The other side, let's say this is y and this is w. Now the next thing is we will try to get the value of y and w in terms of x so that we can get the remaining two sides which I am checking them out. Okay, these two. So that is the main target. Let us try. So the first area is 3. I'll write half base times height is equal to 3. That gave me the value of y as 6 over x. Similarly, I will write for the other one half x times w is equal to 2. So that will give me the value of w as 4 over x. Now, if I write the value of w as 4 over x, the remaining value on the other side will be x minus 4 over x. Similarly, the remaining value on the vertical leftover side will be, because the value of y is 6 over x, it will be x minus 6 over x. Now all we need to focus on the triangle whose area is 4. We will be using area of triangle again, and we will try to get a quadratic. We will solve for x and then we will get x value. Okay, before we begin with that, I'll just write down area of square. So if in case we get x square also, our work will be done. We need not find x only. So area of that triangle with 4 centimeter square area will be half x minus 4 by x. If you solve it, it will be x square minus 4 over x. Let me remove these multiplication sign. Instead, I will put dot. And the other one will be x square minus 6 over x. If in case anyone is having confusion, I'll just tell you that how I'm getting that x square minus 6. So it will be solving these two. So it will be x over 1 minus 6 over x. It will be x square minus 6 over x. The same way I got x square minus 4 over x. Okay, and that is equal to 4. Now in the denominator on left hand side we have 2x and x, that is 2x squared multiplied with 4 will give me 8x squared. So I have x squared minus 4 and x squared minus 6 is equal to 8x squared. Now as I was telling that we need to find x squared, and this will become a biquadratic which will be difficult to solve. So for time being I'll assume x squared as t. So now my equation is t minus 4 t minus 6 is equal to 8t. That is quite easy to deal with. I'll expand and I'll get t square minus 6 minus 4 minus 10t plus 24 is equal to 8t. That will give me t square minus 18t plus 24 is equal to 0. You can use formula method or you can even use calculator to get t value. The two t values which we are getting from here is 16.55. Let me just get the exact value. Just hold on. So 16.55 and 1.45. Now you need to use your common sense over here that let's say t is what? T is x squared. So x squared has potentially two values. One is 16.55 or it will be 1.45. Now if you use 1.45, then 1.45 minus 3 minus 2 minus 4 will take you to the negative answer, which is practically impossible. So with that point, we can consider 16.55 as the right value. We need not find x value. Remember, we were finding x squared because area of square is x squared. Okay, so finally, I am almost close to my answer. So my final answer will be 16.55 minus 3 minus 4 minus 2. Okay, so 16.55 minus 9, that will give me 7.55. Okay, and this 7.55 is the area what they were asking. Okay, so I hope that the whole method is clear. Okay, the process what we followed is clear. This is the bare minimum requirement to solve such type of question. So I hope that you are clear with it. If you really like this video, if you understood question well, then please share it with your friends. We'll see you in the next lecture. Thank you.